Good afternoon, brothers and sisters. It is 1:32 p.m. Central Standard Time on February the 17th, 2022. Hope our Creator is keeping you well and safe wherever you are in the world. Please make sure you hit the like, share, and subscribe button, and ring that bell for critical future updates when we get them. Look at this bad boy. This is from the other day. This is the 15th, how it's kind of blasting off this way, right? Well, we're actually taking some of it, believe it or not. In the grand scope of it, we're taking 60 centimeters cubed, which is as high as the scale goes. The most dense amount, as our scale gives us, we're going to be taking it on the 20th at 0812 UTC time. So Central Standard Time, that would be 2:12 in the morning. I will be keeping an eye on this to see if it changes, because, it can change speed and space on its way here. So yeah, that's not good. Now, what could be causing this? Well, let's go take a peek. This guy right here does not yet have a sunspot name. This is on the far side of the sun, which we are not able to see. However, there are satellites there that we do not have access to, that NASA and others do, and they're able to. That's how they're able to get this photo. Look at the size of that umbra. Whoa. Yeah, that's going to be massive. Oh, yeah, this is going to be coming around to us here before too long. This is Earth side. Okay, this is on the far side, and it's coming around this way. So it's going to be facing us before too long. Let's hope that this thing, breaks apart. Because if it stays like that and it's got these friends to play with, ooh, that's not going to be good, folks. We are here at spaceweather.com, and we're looking at co-rotating interaction region, NOAA. Yes, Noah, as in Noah and the flood, like from the Bible, Noah. Forecasters say that a co-rotating interaction region, CIR, could hit Earth's magnetic field on February 19th. CIRs are transition zones between slow and fast-moving solar wind streams. Solar wind plasma piles are in these regions, producing shock-like structures that can spark bright Arctic auroras. And I love auroras. I used to live in Michigan. I used to love seeing them all the time when I could. North Dakota, you've got them too. Occasionally. New images from the Solar and Heliospheric Observatory, or SOHO, are giving us a better look at yesterday's far-side explosion. SOHO chronographs recorded the most dramatic CME in years. That's right. That's why I told y'all I hadn't seen nothing like this, like ever. This was massive. Now, we are going to scroll down a little bit here. No, there won't be a geomagnetic storm. I beg to differ, but whatever. The explosion happened on the far side of the sun. Yeah, even though we've got, look at this, a halo CME. It comes all the way around, but hey, no storms, no nothing from that, right? Some readers have asked, how strong was the underlying solar flare? We don't know. Solar flares are classified by their X-ray output, but there is no spacecraft on the far side of the sun with X-ray sensors. Oh, notice how they said there isn't any on there with X-ray sensors, but there are still spacecraft on the far side. Best guess is it was an X-flare. Yes, it was. It was massive. You might suppose that the far side of the sun is hidden from view. However, researchers using a technique called heliospheric can make crude maps of the sun hidden hemisphere, which is what we looked at here. Black blob is a sunspot group, a big one. They really emphasize that. And it is likely the source of the explosion, according to John Zhao of Stanford University Heliospheric Group. Active region this large are rare, and yes, that is true. This is only the second far-side activity of the region of this size since September of 2017. Yeah, I would have to agree with that too, actually. Solar scientist for Harvard Smithsonian. Well, I don't believe anything the Smithsonian has to say. Believes an active region might be an old friend. Okay, I'm just going to disregard that. I don't even listen to anything Smithsonian says. If so, it is the same sunspot responsible for the geomagnetic storm that downed the SpaceX satellites on February 4th. That's possible, but I doubt it. Like I said, I don't believe anything the Smithsonian says, because those diggum SpaceX satellites should have never fallen down. They were shot down. Yeah, and if Smithsonian tells you something, yeah, look for the BS, because that's exactly what it is. Let's go see if we got any meteors coming towards us at all. Well, let's see, today is the 17th, so we got nothing that's super close. Looks like tomorrow we've got one that'll be 2.2 lunar distances, 25 meters, so that'd be about 75 foot around. So, and then the next one would be the 19th, be 2.8. So yeah, but it's only 9 meters, so that's not too bad. 27 feet. This one and this one would actually break up. Well, this one might have a little bit that could actually impact at 25. But 9, that would just burn up in the atmosphere. So it's looking like we're doing pretty good so far. Nothing super worrisome. At least not right at this point. So let's come on over here to LASCO C2 and C3. And one of the things I want to show, and I know I got some new subs, is obviously this one right here. This is from the 14th, just a couple days ago. We've got a nice little friend right there, a little spaceship right there. And then over here, we've got battle formations right here. You can clearly see them going this way. Now, we're going to actually take over. This is LASCO C2, and this is LASCO C3, as you can see up here, okay? We're going to scooch forward a little bit till we can get to our explosion, which is actually coming up here just a second here. And we're seeing that coronal mass ejection coming off the surface of the sun. And if you notice, there's a large time gap right there. 22:36, 23:12. Almost a full hour. They do that to us all the time. They're always removing data. So we are going to get some of this. Man, that is a beautiful eruption, isn't it? Oh, look, there's a little friend there. There's another friend there. They're all over the place. In fact, if I'm not mistaken, there's a Borg cube on this one, too. Ooh, look, there's another friend right there. There's another one right there. They're all over. Where's that Borg cube at? Oh, come on. Oh, there he is. How you doing, buddy? There's one of our Borg cubes, and you can see that he's bending the light like this. And look at this. We got another little friend right over here. You see his little trail of la 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 coming up behind him. So you got a Borg cube and a friend right there. I hate it when they continuously hide stuff from us. It's like, just quit it. We have the right to see it. Even though there's nothing a whole lot we can do about it at the moment, we still want to see it. There's a friend there, a friend there. You can always tell because they got a nice little trail of la 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 coming out behind them. And for those that are not quite sure what I mean, I'd really love to show you. I'll show you over here on the blue, which is LASCO C3. Oh, we got another Borg cube right there. You can see it bend on the light there. And it actually projects the light bending, which is really cool. And I think that's about all of the excitement that we got there. Might be a couple other friends here and there. But let's come on over here first. Alright, we'll just come on over here to LASCO C3. I'm going to show you guys something. The reason I know that these are friends instead of like asteroids or comets, because I'm going to, ooh, look at that. Right here's a signature trail. And if we zoom in on it, you see all these little bright lights that are inside of this trail? Those are actually, it's called a nuclear pulse engine drive. Yes, just like Star Trek, the pulse engines, same thing. We have a nuclear pulse engine drive. It's on the TR-3B. You can look it up. It's actually patented, NASA. But yeah, that's what these are. It pulses. It goes boom, 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 boom. It actually pulsates, and that's how it accelerates. So we got that one. Now let's get to right before we get our pop. Where is it at here? Pardon me, sorry. Alright, we're going to be getting it here any second. Where are you? Oh! Where's the comet? Okay, here we go. Right here, you'll see the explosion. And right here we have a friend. And he's got a little trail of la 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 coming up behind him. Okay, this is definitely a spaceship. It's not a comet. It's not a meteor or an asteroid. The reason I know that is, you see how he got the trail of la 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 come out behind him? Now, I want you to watch right. Where is it at? Where's my little guy at? Oh, there he is. I'm over here looking for him, and I couldn't find him. Okay, right here. This little white dot right here. Let me zoom in for you right here. Okay, this white dot right here. See that? Now watch it. That's a comet or a meteor, and that's another one right next to it. Well, it could actually be a proton torpedo. Who knows? But you notice it's moving steadily towards the sun. That is what that is. That is a comet, or two comets, or meteors, asteroids, however you want. Okay? So, notice how this guy here's got his little trail of fla-la-la behind him? Where's his trail of fla-la-la-la behind him? He ain't got one. See that? In fact, there's two of them there, and they don't got that. They don't have that signature. So, these are comets and meteors moving steady straight towards the sun to do a little rotation, to do its little orbit. Just like that. Oh, look at that. Here's a friend right here. How you doing, buddy? So, yeah, this is a comet, or a meteor, if you will. You can see a teeny little low trail coming off the backside right here. That's it. Just a teeny little low. That's it. So, when we're seeing some of our other friends, like this guy here, doesn't have a lot of trail coming off behind him. He could be in a glide, but I mean, there's one right here. And he's actually coming right towards the satellite. You can see the little trail coming up behind him, the little fla-la-la behind him. And they move. They don't just like have a slow rotation where they're slowly heading towards the sun. I mean, every single one of these is a 12-minute. Well, some of them are 12 minutes, some of them skip hours like that. But they're 12-minute intervals. Okay? So you're seeing a meteor moving towards the sun, or asteroids, or comet, whatever you want to call it. But 12 minutes between frames. But we'll see our friends in one shot, then they'll be gone the next. Because they're moving a whole lot faster than a damn comet or a meteor or asteroid or whatever you want to call it. They're moving way faster. So, anyway, stay safe out there, folks. Remember, love is the only way forward, and I will keep my eyes open and let us know as soon as things change or things happen. God bless.